Hello my friend, happy to see you here. Today let's solve this great and relaxing algebra question. We have system of two equations. The first equation a plus b equal to 10 and the second one a times b equal to 30. We need to solve this question for a and b. So of course right now we can easily check you can easily test your school knowledge, your algebra skills, and you can pause the video and try to solve this question with me. Write your solution in the comments below. It will be really interesting to check our answers, to check our solutions in the end of the video. Okay, we have a basic system of two equations, and what is the best way to solve this one? We need to express, for example, from the first equation, I'm going to express our b. So our b is equal to 10 minus a. 10 minus a. And right now, I'm going to plug in, instead of this b right here, I'm talking about second equation. I'm going to plug in, instead of this b, I'm going to plug in 10 minus a to the second equation. Okay, so let's do it. So we have a times 10 minus a, and equal to 30. Okay, really great. Right now let's simplify this expression real quick. So we have 10a minus a square and equal to 30. Okay, what we're going to do next? If you look at this question from a different angle, we can easily see that this is a quadratic equation, but we prefer a little bit different order. Minus a square, let's write on the first position, plus 10a, let's write on the second position, and minus 30, let's write it on the left side, but with a negative sign, equal to 0. And right now we can easily say, okay, looks like this is a quadratic equation, but we don't like this negative sign right here. So that's why my quick hand is to multiply both sides by minus 1. So as a result, we have a classic order of signs because it's much easier for us to work with the positive sign right here. So we have a classic order of signs, a square minus 10a and plus 30 equal to 0. Okay, what are we going to do next? Right now, let's write our coefficients quickly. So a equal to 1, because this is a classic quadratic equation. B equal to minus 10. And c equal to 30. So right now let's solve it for a first and a second, because this is a quadratic equation. It implies that right here we have two roots. But first of all, I'm gonna solve real quick for discriminant. So b square minus 4ac. Let's solve real quick for discriminant. So b square minus 10 square minus 4 times 1 and times c times 30. So as a result, we have 100 minus 10 square, 100 minus 4 times 30 equal to 120. So right here we can see that we have negative discriminant. It's great, but in the same way we can easily say that right here we have two complex roots. If we have, for example, a positive discriminant, so I'm going to write right here a special case, like if discriminant is positive, so for example we have d equal to, for example, 10, it means that greater than 0, so two real roots. Okay, if we have negative, so two complex roots, doesn't matter, let's solve it. So we have a first and second equal to so minus b plus minus square root of discriminant and all over to a. So all known formula, and let's plug in. We know everything. We know discriminant, we know b, and we know a. So minus b minus 10 plus minus square root of discriminant square root of minus 20 and all over to a 2 times 1. Yeah, really great. What are we gonna do next? Minus 10 equal to 10 plus minus square root of minus 20. This is not a table case, but my quick tip is to express this as a product. So first of all, minus 1 times 4 times 5, the best way, because 2 times 10 is not a good, 4 times 5 is good. And right now I'm going to say why this is good for us, because square root of a product equal to product of square roots. So as a result, we can split it. We can write as square root of minus 1 times square root of 4 times square root of 5 over 2. Square root of minus 1, this is our imaginary unit, this is our I. Square root of 4 equal to 2, so we have 10 plus minus 2i square root of 5, yeah, and dividing by 2. And the final moment, we can divide our numerator by 2, but by parts, 10 over 2 and this one over 2. 10 over 2 equal to 5, so we have 5 plus minus. So a first, let's write with the positive sign. So we have 5 plus I square root of 5, And the second one, a second equal to 5 minus I square root of 5. This is not a solution to this question because we need to solve it for a and b, for pair. So in that way we need to go to the beginning, because in the beginning we had b equal to 10 minus a. This is our expression from the beginning. I just want to rewrite it right here. So b equal to 10 minus a. So as a result, on this side we can find b first equal to 10 minus a first, and right here b second equal to 10 minus a second. Yeah. So right now let's solve, for example, for b first. Yeah, let's do it. So b first equal to 10 minus a first. This one, 5 plus I square root of 5. b first equal to 10 minus 5 minus I square root of 5. 10 minus 5 equal to 5, so b first equal to 5 minus I square root of 5. Okay, and b second equal to 10 minus a second equal to 5 minus I square root of 5. So we have a symmetrical roots. Yeah, we have b second equal to 10 minus 5 and plus I square root of 5. Okay, so b second from here equal to 5 plus I square root of 5. And if you look closely, b second 5 plus I square root of 5, a second this one, b first this one, and a first. So we know everything. We have symmetrical roots, and let's write our final answer. So our answer to this question, first of all, with the first index, so we have a first, b first, so 5 plus I square root of 5 and 5 minus I square root of 5. Second parenthesis, 5 minus I square root of 5 and 5 plus I square root of 5. Okay, really great. So we have our answer. We have two pairs, and in the end, let's check our roots. So let's prove it. Let's check it. First of all, I'm gonna write our system. So we have a and b equal to a plus b equal to 10, and ab equal to 30. So right now let's check addition first of all. Yeah, a plus b. Let's check, for example, this one or this one, doesn't matter because we have addition. A plus b is the same as b plus a. So we have 5 plus I square root of 5 plus 5 minus I square root of 5. Real quick, canceling this one. 5 plus 5 equal to 10. Yeah, so we have 10 right here, so our addition works perfectly. What are we going to do next? Let's check real quick our multiplication. So our multiplication, we can check only one of these pairs because right here we have multiplication. So a times b is the same as b times a. Moreover, we have absolutely symmetrical roots. So for example, check this one. So a times b equal to 5 plus I square root of 5 and 5 minus I square root of 5 equal to 30. But let's check it. So first of all, we can multiply parenthesis by parenthesis, but this is our school identity. I really hope you remember, you learn this school formula when we have x square minus y square. This is maybe the most popular formula. We have x plus y, x minus y. So this is exactly our case. X plus y, x minus y, but x equal to 5, y equal to I square root of 5. So that's why this is a difference of squares. So we can consider this as difference of squares. So let me continue it, for example, right here on the right side. So difference of squares, 5 square minus I square root of 5 square. So 5 square equal to 25 minus I square and square root of 5 square. So I square equal to minus 1. So we have minus, and square root of 5 to the power 2 equal to 5. We just cancel this square root sign with this 2. So 25 plus 5 equal to 30. So yeah, this is a correct root. Yeah, AB equal to 30. We just prove it. So I really hope you understand my solution. I really hope you learn something new, but definitely don't feel bad if you got this wrong. If you need help, if you're struggling with this type of questions, I have a lot of challenges, a lot of questions on my YouTube channel, a lot of system of equations, a lot of different entrance examinations question, a lot of Math Olympiad questions. So I really hope you learn something new. And if you're talking about this question, write your thoughts, write your response in the comments below. A lot of teachers, a lot of students here, and I think everyone will help you. According to this question, this is not a hard question. This is a classic system of equation, and that's why I solve this question step by step, because maybe a lot of students here, so that's why I use this basic method and basic quadratic equation and basic answer. This is not a complicated question with sine, cosine, with integral, with derivative. We have a classic school question, but sometimes I see this type of question in entrance examination and a different Math Olympiad question, because a lot of teachers make this type of question, and that's why I record this video, because this is a great question with a complex root. So it's a great moment to practice it. If you, for example, if you're struggling with a complex root with this system of equations, it's also really great to solve this question with me right now. So thank you everyone for your time. Take care of yourself. Have a great day, and see you in the next videos.